So the example number 1 says find the volume of the solid created by revolving around the region enclosed. So it's enclosed by y equals x squared plus 1, y equals 2. That's what it's enclosed by. It's enclosed by y equals x squared plus 1 and y equals 2. Okay? So y equals x squared plus 1 is the red. Y equals 2 is the blue. And then the x-axis is the green on mine. So the area enclosed by x squared plus 1 and y equals 2 is this area here. Okay. That's the area enclosed. All right. So now we have to find the volume. Okay, again, I know this is part of the washer method notes, so it's going to be a washer method. But what tells me that it's going to be washer method?
There's space between the bottom of the line and the x-axis.
There you go. There's space between, this is how you know. This is how you know. It's the dead giveaway between if it's washer method or disk method. There's space between the shaded area and the axis of revolution. What color is my axis of revolution? What color is it? Green, right? It's green. And then the shaded area is up here. There's space between them, right? If there's space between them, it's going to be washer method 100% of the time. Look at the graphs from yesterday. The axis of revolution was the x-axis. Is there any space? Is there any daylight between the axis of revolution and the green? Nope. They're right on top of each other. They're right on top of each other, right? Right on top of each other. All of those were disk method. So that's why this is washer method. Okay, I'm telling you right now because I get this question every test. We take this test. Mr. Flores, is this disk method or washer method? I can't tell you. Okay, so that's what I'm telling you right now. So put it in your notes so that you can put it on your little card when we take the test. But yeah, that's how you know if it's disk method or washer method. Is there any kind of daylight between the shaded area and the axis of revolution? Yeah, there is. Okay, so this one's washer method. Okay, so we know it's washer. Okay, so washer. Go ahead.
What if it gives us a question like how we got on the practice last time, where it's like asking for the shaded area of two different areas, but they both touch the x-axis? Would that be?
If there's any kind of daylight in between any of those shaded and the axis of revolution, then it's washer. Okay, so it just depends on where the axis of revolution is. If it's a horizontal, like this one's a horizontal, right? Horizontal, the axis of revolution about the x-axis, right? That means dx. Okay, so once I know all that, I'm going to set up my guy up here. So again, we're still dealing with circles. Disks and washers are circles, circular, so that's why we have pi. So we got pi. And then I'm going to leave everything blank for right now. Okay, and I'm going to fill them in as I go. Okay. Big R. So big R extends from the axis of revolution to the outside of the shaded area. So I'm going to go make a dot below the shaded area on the axis of revolution. I'm going to go make a dot. So it can't be over here. My dot can't be over here in orange because I'm not below the shaded area. Right? I'm not below. I got to be below the shaded area. So anywhere, right there is fine. I'm below the shaded area now, right? And I'm going to extend until I get to the outside of the shaded area. I'm going to keep going up until I'm on the outside of the extended area. So I'm going to go up, 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 up. I'm just on the inside now. There, I'm on the outside. That is big R. Little r is the same thing. Start with a dot below the shaded area, except this one only extends to the inside of the shaded region. I'm not going to go through the shaded region. I'm going to just go until I hit the shaded region. So I go up, 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 up. Before I get to any shade, I stop, and that's little r. Okay? That's the hardest part. Believe it or not, that's the hardest part. Because once you identified the two dots and big R and little r, just put them right into your calculator. Or put right into the equation first and then your calculator. Okay, so let's go back to big R. Big R, this is dx, right? Dx is top minus bottom. So where is the top dot?
2.
Y equals 2, right? Y equals 2. So we're going to go 2 minus, where's the bottom dot for big R?
0.
Y equals 0. Yeah, you want to say that because I see a 2 over here, but that's not what we're talking about, right? I see a 2 over here, that's not what we're talking about. So just to the line, right? So 2 minus 0. Now little r. Where is the top of the little r?
Y equals 1.
Or
I mean
1
2.
point, 1 point something.
Where is the top dot?
Y equals x squared plus 1.
There you go. It's on the red. Y equals x squared plus 1, just like we did yesterday. Where is the bottom dot?
0.
What function is the bottom dot?
Y equals
There you go, minus 0. All right? When I put them in here, I'm talking about functions. I'm not talking about points. I'm talking about what function is it on, right? Okay? All right. Bounds. Bounds. Where are the bounds for the shaded area?
-1 to 1.
Let's see. Bounds for the shaded area. So do I want top and bottom bounds or left and right bounds? Left and right, good. So left and right, let me use a color I haven't used. We'll use dark green. So there's one there, and there's the other there. Left and right bounds, right? So do I want the x value or the y value for these guys? The x, because it's dx. So what is the x value for the left dot? -1. So you're going to go over there, and you're going to put -1. What is the x value for the right dot? +1. That's as much as you need to do. The rest of it is in the calculator. Anytime you're putting things in the calculator, I see this every time. Try to make the things you put into the calculator as simplified as possible, because there's a lot of things that could go wrong here. And on a test, I'm like, sorry. So what I do is I simplify as far as I can. Like 2 minus 0, I think I can figure out what 2 minus 0 is, right? What is 2 minus 0? 2, and then 2 squared? 4. I can simplify that, right? It doesn't take much thought to do that. So before I put it in my calculator, I'm going to simplify this to 4. And then I know what x squared plus 1 minus 0 is. X squared plus 1. That is a lot easier to put in than the first one. They're both right, but I see this a lot. I see this, it's not working, Mr. Flores. Simplify it, right? Simplify it. Simplify before you put in. Now you can put that into your calculator and tell me what you get. You get 13 point something. So I got 13.404. Do I need to do it? Do we get something different?
No,
That's what you guys got?
yeah.
Okay. Then I won't have to. Okay. All right. All right, let's go look at the next one. First thing, it's very similar, right? It's very similar. So the picture is going to be very similar except for one or two things. So give me a picture. First thing you're going to do is give me a picture. So a lot of the functions you have already in there in the grapher, you don't have to change. I still want y equals x squared plus 1. Still want that guy, okay? I still want y equals 2, okay? I don't want y equals 0. I want y equals -1. So I'm just going to put -1 there. Okay, so there's 3 graphs on this particular graph, just like the last one. The shaded area is exactly the same as the last one. Okay. So as you're drawing it, what's the difference between this one and the one we just had?
There's going to be a bigger little r.
Yeah, because you're right, Isaac. There's going to be a bigger little r, actually a bigger r as well. Big R, why? What's causing that?
That it's going about.
The center is divided.
Yeah, what do we call this? What fancy name does this guy have? Axis of revolution is farther away from the shaded part, right? It's revolving around something that's farther away. So yeah, big R and little r are going to be farther away. Yep, for sure. Again, there's daylight between the axis of revolution and the shaded part. So it's got to be a washer problem. It's got to be a washer problem. Okay. So we still have y equals x squared plus 1, and we still have y equals 2, but now we have y equals -1. So is this dy or dx? Because the line we're revolving around is horizontal. The green line is where we're revolving around. We're revolving around the green line. Okay. All right, so let's set up. Okay. So one more time, big R. Big R starts on the axis of revolution. The axis of revolution for this guy is down here, underneath the blue, underneath the shaded part. And I'm going to keep going up until I'm out of the shaded part. So I'm making my way. Okay, now across into the shaded part. All right, there I'm going to stop. I'm going to stop on the function at which I'm leaving, right, on the other side of the shaded part. That's called big R.
3.
Yeah, we'll get there in a second, yeah. Little r, start underneath the blue shaded axis of revolution and go up until I get into the blue. I don't want to go into the blue, so I stop. That's little r. Okay, so big R, top dot. What function is the top dot for the big? It's y equals 2, right? Y equals 2. So 2 minus, What function is the lower dot for big R?
-1.
Y equals -1. So we're going to put -1 there. So essentially you're just adding plus plus, right? So it's 3. 3 squared is 9. Okay, now let's go to little r. Top function, top dot for little r.
X squared plus 1.
X squared plus 1 minus
-1.
-1. That's the lower dot, right?
That would just be x to the 4th.
So now before we do that though, we got to do the bounds.
-1, +1.
So the bounds, are they at the same spot
Yeah.
they were before, the left and right? They are this time. They're here and here. So remember, we want x because it's dx. X equals 1, x equals -1. -1, +1. So we get 3 squared, which is 9, minus. Over here we get plus plus, so it's x squared plus 2, quantity squared. Okay? That's as far as you need to go. Let the calculator do the rest. Let the calculator do the rest on that one. Yep, that's what I got. Verify that you can get that. So this one's got more volume, right? This one's got more volume because it's a longer shape, right? Those R's are longer. Big R and little r are longer. So if they're longer, it creates a bigger shape, bigger figure. That's why the volume's a little bit bigger. Okay. All right. Okay, so let's go to page 3. Let me see. So I want you to do this one on your own. Do example number 3 on your own. Okay? Do example number 3 on your own, and then I'll meet you on 4. Okay, I'm not going to do the problem yet, but here's the graph, finding the enclosed area too. So the enclosed area, the shaded part, goes from the curve. So the curve, y equals -2, and the vertical lines x equals 2 and x equals 0. So the shaded area is going to be this part here. That's going to be where the shaded region is. And I'm revolving around y equals -4. So I'm revolving around the pink. So the pink and the shaded area, there's daylight in between them. So that's why it's a washer problem. It's not a disk like we did yesterday. Okay. And it's dx because we're revolving around the pink line, and that's a horizontal line. Okay, so big R. I start underneath on the axis of revolution, which is here, and I go up until I leave the shaded part right there. Any farther, and I wouldn't be in the shaded part anymore. So that's R. That's R. The other one starts below, goes up until I get into the shaded part. That's R. Okay? So the function at the top of big R is y equals e to the x, the red, minus the bottom, which is y equals -4. So you go e to the x minus a -4.
region R, is that V or,
So region R is the shaded area.
so it would be V? Or,
What are you talking about?
because it says region R is.
The area.
Function f of x
Yeah, it's the
equals-
shaded area.
Region R is the shaded area. It's
These
that.
ones rotated.
V is, yeah, the shape that's created when it revolves around, yeah. So yeah, if we wanted to find just the area of that, we would use region R. But since we want volume, that's why we use V. Good question. Okay, so that's going to be a plus plus. Little r starts at -2 and it goes to -4. So -2 minus 4. The bounds. 0 to 2. 0 to 2. X values. Simplify. The first one you can't really simplify besides making them addition. So I would just leave it at e to the x plus 4 squared. The other one you can.
36?
Yeah, it's just going to be 36 because it's going to be -6 squared, which is positive 36. Wait, no, sorry. I messed up. It's -2, but then you're subtracting what?
Negative.
-4. So it's actually going to be +2 squared, which would be 4, yeah. Yeah, sometimes those negatives. Okay. So when you put that in your calculator, you will get 320.164.
Is the reason this is significantly more volume, is it because there's like a smaller little r and a
Yeah,
big?
that's a good point. Why was this one bigger than the other one significantly, right? The shaded area is pretty big and R is tiny, so that means a tiny hole, yeah.
Got it.
Yeah, good question. Yeah, so if little r is small, it's going to be a bigger volume, yeah. Okay. All right, so I want you to try number 4 on your own as well. Try number 4 on your own, and if we have time, we'll do another, but if not, we'll finish tomorrow.
Mr. Flores, will they ever ask us for like half of something?
Half of,
Like, say it's like the washer method, but it's not asking us.
and then the bounded region's kind of this diagonal little sliver here. And we're revolving around y equals 6, which is a horizontal line. So again, it's dx. So when you're sketching it, like I said, just draw the curve doesn't have to be exactly perfect. You know, the lines are a little more easy to draw since they're straight lines, but the curve doesn't have to be like perfect. Just get your picture to look something like mine. That's enough. Okay, that's enough. Don't try to be too perfect. You're just trying to get a picture in your mind so that you know what the top and the bottom are, you know what big R and little r are, those kind of things. Okay.
Mr. Flores, what value did you use when you were finding the upper bound? Because for.
Oh, okay. So yeah, I haven't done it yet. You're talking about the bound? Yeah, you're talking about the bounds, right?
Yeah, the last bound, because the bound, the right.
So it's going to be this guy here and this guy here, right?
Yeah.
So I'm going to have to use the calculator to figure out where the blue and the red intersect.
Yeah.
So for those, I got 0.1456, and the other one I got 8.2109.
And R is where it touches the top, right?
So big R and little r always start on the axis of symmetry. So I'm going to make a dot. This time, we haven't seen one like this, right? All of our axis of symmetry, axis of revolutions have been below, right? So now we're above. Well, it doesn't matter. You start there. This time we're going to start above the shaded area. Anywhere above the shaded area. And I'm going to go down this time until I get on the other side of the blue. So I'm going to go through the blue. I'm going to go extend through the blue until I go to the other side. That's big R. Little r is going to be the same, except I'm just going to stop when I get to the blue. Okay. So for big R, you're going to go top dot function minus bottom dot function. And then same thing with little r. So big R is y equals 6. Yeah.
When you put it in that way, you have to flip them, otherwise the answer's like negative 360 something. Or-
Flip the...
Yeah, because when I was putting it in and I did the top, like I did
Yeah.
6 minus,
Yeah.
it gave me negative 480. But when I flipped them and I did the function minus 6 instead, it gave me the right answer.
Yeah, I think it's because natural log is technically the top.
Let's see. Yeah, in my notes I have it different. Let's check. Let me do this and then we'll check it out. Yeah.
Okay.
So we got 6 minus the blue, which is 1/2 x minus 2, right? And then little r is 6 minus the red, which is the natural log of x. Okay. So the bounds I just found by using my calculator, figure out where they cross. 8.219, 0909. So here what I'm going to do is I'm going to distribute the negative. So when you distribute the negative, when I distribute the negative, it's going to be 6 minus 1/2 x, and then plus 2, right? So it's going to be 8.
I thought the positive answer by plugging everything in.
Yeah, we'll check it out. We'll check it out. And then over here, I can't really do anything because it's natural log, so I'll just leave natural log of x squared dx. Yeah, this will be the last one we do. We'll make this one the last one because I want to take time to do that. So I distributed the negative. That's why it's negative 1/2 x. And then I distributed the negative again to make positive 2. So that's why I could combine it to make 8. Okay? Okay, yeah. So let's put this one in the calculator. Okay. So I have integral okay, so we have 0.1456, 8.2109, parentheses. Okay, so 8 minus, oops, why did I put 6? 8 minus 1 divided by 2x. Oops, I don't want x down there, I want x. There. Close parentheses, squared, right? Okay. Minus, parentheses again, 6 minus natural log of x. close parentheses twice, right? Because the whole thing is squared. Okay. Let's make sure. Minus. Okay. Oh, I forgot to put the pi in front too. I forgot to put the pi in the front, so I'm going to have to multiply my answer by pi. So my answer is not what I told you, right? Because I need to multiply times pi. So I'm going to take my previous answer, or you can cut and paste. You can go up here, cut times pi, and there you go. 312.752.
If you just flipped it, what's the difference? Why did it work that way?
So flip which part? Which part did you flip? What do you mean flip it?
I subtracted 6 instead of the functions.
Oh, you're talking about, so this guy here, you did it like that?
Opposite.
So what did you, let me see.
I think she said she did the functions minus 6.
Okay, so let's try it. Let's try it. So what did you, let me try it. What'd you put into the first set of parentheses?
The function minus 6
So negative 1/2 x plus, was it plus 2 or minus 2? Minus 2, right? Minus 2. Okay, so I got to put that in parentheses because that is a function. And then
minus 6.
-6. Oh, I know why. Because you have the same signs, right? We had, so we had +6 and negative function, right?
So it just works out
Yeah.
when you do this.
Because it's the same thing. You're essentially the same thing because you're just flipping them, right? In math, it's weird how that works. Something totally the opposite is actually the same. Yeah. So yeah, that's why it worked because yeah, it was the same. Yeah, I've never heard that, but it works. Yeah, it works mathematically. It's correct because yeah, like in math, it's weird because everything that's the same is the same, obviously, but everything that's completely different is actually the same. So that's why it works. Yeah. Okay. All right, so the only other thing we have is dy. We haven't seen any dy's. We'll do those tomorrow. So the rest of the problems, not the rest of them, but a few of them are dy problems. We haven't seen dy yet, so that's what we're going to do tomorrow. Okay?
Maybe